In this video, I'm going to show you some basic differentiation. What I have over here on the right-hand side are the rules that we know for differentiation. Here's constant multiple, here's addition subtraction, here's constant, here's the derivative of a line, and here's the power rule. So let's go ahead and do some problems where we're applying these rules to differentiate these expressions here. Now, you'll notice that I'm using a lot of Leibniz notation. So I really like writing d dx to say, take the derivative of what follows. Now, the first thing I'm going to do, since I see differences and sums, is break this into pieces. And I'm going to break it into 3 pieces. So in particular, I'm going to break it into that piece. I'll be using eventually power rule on both of those, and that piece because it's a line. So this is going to be equal to d dx of 3x to the 4th minus d dx of x squared plus d dx of 2x minus 3. Let's think about what we're going to do with each piece of this. What we're going to do here is we've got x to the 4th. We know how to differentiate it, but there's a 3 in front of it. So we're going to pull the 3 out using the constant multiple rule. So this is 3 d dx of x to the 4th. Alright, next piece. Well, this is the derivative of x squared. By the power rule, that's 2x. Plus, this is the derivative of a line. The derivative of a line is its slope, so that's plus 2. So all I have to do now is take care of the power rule here. According to my power rule, what I'm supposed to do is take the 4, put it out in front, there's my x, and subtract 1 from my exponent. So that's 3. So this becomes 12x cubed minus 2x plus 2. Let me emphasize something here. I have done this in a very step-by-step, show every detail manner. You do not have to do this. So if you feel comfortable with differentiating, let me show you how you might want to do this. So again, this is just if you're going, yeah, I know what I'm doing. Here's what you can do. You can say the following. Oops, let me change back to a pencil. There we go. The 4 comes down, hits the 3. 4 times 3 is 12. And we use the power rule and subtract 1 from that exponent to get 3. We hit the minus sign, differentiate x squared to get 2x, differentiate 2x minus 3 to get 2. Eventually, I want you to get to this point, but it may take some time, and you do want to be careful as you're getting to this point. So, when in doubt, go step by step. Let's do this again with the problem in B. So now what we want to do in B is we want to take the derivative with respect to x of the square root of x plus x. Now there are 2 things going on here that we need to pay attention to. First is we've got a sum, so we're going to be breaking this up. But we have square root of x. None of these rules over here specifically mention square root, but they do mention exponents. So it's very important that you're able to rewrite expressions. So I'm going to say, instead of square root of x, x to the 1/2 plus the derivative of x. Now, for this first term, we use the power rule. The exponent comes down, so that's 1/2 x to the 1/2 minus 1. I'm going to write it out this time because it involves a fraction. We come over here. There are a couple of ways that we can address what the derivative of x is. My favorite is to think about the fact that this really is a line with a little invisible slope of 1 right in front of the x. So when we take the derivative, we just get 1. You can also get the same answer by applying the power rule. Either way, our final answer is 1/2 x to the negative 1/2 plus 1. If you want to, and this is not necessary, you can rewrite the answer there. So it's 1 over 2 times the square root of x plus 1. For right now, and for most of Chapter 3, I'm not going to be very picky about how you write your final answer. So this format is fine, but if you want to, change it to that format. Alright, this is a review of some of the basic differentiation techniques that we're covering in section 3.1. Get some practice with these. The better off you are with these, the better off you'll do later in the class.